So, and we have to wait for 10 minutes. Even in India, if any meeting goes on, after 45 minutes, we rejoin so that it is free meeting. Because 10 minutes for a host. Like if we both are doing and we don't have any access, so I will do it for the first 45 minutes, it will end it. But you can do it immediately because you are new host. I will have 10 minutes of slack time. So 45 minutes again over. Then I will do, you do, I do, you do, like that. So like that we conduct 3 hours, 4 hours meeting, 45, 45, 45, 45. Changing of hosts.
Okay, go ahead, Shri. You can continue. Shri, I have clinic on Monday, okay?
Yes, Dr. Nar. I have seen on your schedule this Friday you have some patients.
No, I don't. Friday.
I think. I don't know. But
I'm here? How am I? Shri, let me go there to see. The way I'm crazy, Shri, I may have it. Let me see.
and me and Ayan saw last week to know whether in this Monday we have to come to clinic or not. At what time?
Okay, so let me see.
One minute, Doctor.
Start in a second. I hope I don't. And if I do, I'm going to change something. No, Shri, I don't.
Oh, I think next week maybe we have seen.
October 10, right? Friday is October 10. I don't have anybody. Now, on October 13, then I have 5 patients.
Oh, I think. Okay.
And then I don't have any other patient that week also. So it's October 13.
Okay, Doctor.
Okay?
Yes.
All right, go ahead.
So Dr. Nara, what we did is like we two things. Number one, these are the families where individual variant analysis I have looked for OMIM phenotype, and the next one is in the in the Mendelian genomics file we run while selecting the families, the probands of the autosomal dominant and the autosomal recessive ones, and they gave me the file. I will just show you. So in this usually submissions by groups. Oh, this one in the 7 entries. When I go in the first one, I can see in the analyze one where I get here the genochondromatosis autosomal recessive and the autosomal dominant files, the merge analysis. So in this file, after filtering in these two files, I didn't find any OMIM phenotype. They were filtered out. But in these
Okay.
individual files, I found something. So
Okay.
that's what I usually, and this is what I even said here. The same thing. The genes in AD genes are two, with these in the
I
this
see. Okay.
the
I got
no,
it.
but this one is like something like a shorter version. I will remove it. I don't think I need these.
No, it's okay. It's okay.
Yeah.
It's okay.
So and then so Dr. Nara, this one is autosomal dominant, and autosomal dominant. This is the file. So I was like, so I showed you how I did the novel de novo variants, the which had new mutations. So those I marked it as peach, and then this was the second color in the second column in the D. I marked it for all the loss of function variants. You can see the frame shift insertion. This is the loss of function variant in this ref gene. Am I right, Dr. Nara, or wrong?
So,
And in rest of the columns, all non-synonymous. So no frame shift or stop gain, stop loss. Even in this H column I have seen, there is no splicing variant, only exonic. So I didn't mark anything for the
okay.
loss of function. And then the novel variants, I removed everything from the database. I mean, I went to the Hopkins sample, removed it, and I went to the GNOMAD frequency, and I followed certain criteria for the novel variants told by Elizabeth
Mm-hmm.
on selecting this. I know how I did that. Um, yeah, I had to go through four things: the 1000 genome, exome variant server, EXAE, that is exact, and GNOMAD. I have to go
Mm-hmm.
there for looking for all these variants. Mainly I went through three only because there were no 1000 genome and exome variant server in my variant analysis. And
Mm-hmm.
in those two, GNOMAD exome frequency and genome frequency, I had to got it. I had to select only zero, and I removed even blanks. I had to select zero, or I removed rest of the things. And where I found all these genes which are marked in blue. That was the criteria to, and also I removed the Hopkins sample so that nothing is in our database, everything is new. So that is what I have followed for novel variants.
Mm-hmm.
And then I was like, which has these two and which has these two. I included it in here.
Mm-hmm.
Um, the loss of function variant is in one gene, two genes,
Mm-hmm.
and then one gene have family with both, and two genes have families. Family means there was only one family, one gene, two genes in families. I can show that if I have to, if this is important, I will include the table here.
Mm-hmm.
But yeah,
Okay.
so with both
No,
the
it's okay.
yeah, with both, like, let's say both de novo and novel variants, de novo and novel variants, I had to go to two columns here. So I found this one. So this one in this gene, KRTA, and this one in this gene.
Mm-hmm. I
So
got it.
this is one family, this is two family. So I was like, two genes have families.
Mm-hmm. I
So
got it.
yeah, so
Mm-hmm.
similar thing I have done for the, and here, Dr. Nara, I have went through the PLI score and the missense scores
Mm-hmm.
for these genes, and I didn't find anything interesting. I didn't
Mm-hmm.
go through this file here in this Excel sheet, but I went to the GNOMAD and I searched, because in this there is
Uh-huh.
automatically it is not given. So I
Okay.
didn't find anything with the PLI score, and the same thing there, Dr. Nara. The autosomal dominant, loss of function, one gene here, and also I didn't find any PLI score. So that's what I said,
Okay.
not applicable.
Got got it. Mm-hmm. Okay.
Yeah, actually I should say missense. I can say both, because I saw both the missense or PLI. I saw both the missense and the PLI while I was looking at the June, and I didn't find anything interesting in these both. I didn't find anything. And the
All
loss
right.
of
Go ahead.
function, once again I just wrote it here. It is already written, the loss of function, but I have written it here. That's it.
Okay. I got it. Uh-huh.
Because I have to write regarding the PLI score, so I just wrote it here. And here the same thing with the autosomal recessive file.
That's it.
I
Mm-hmm.
found the one gene with the de novo variant, loss of function two genes, novel three genes, and two genes have families. But in entire merged analysis, I didn't even find one NDL variant which has all novel de novo loss of function variants. So that was kind of sad, because that removed my classification. Like tier 1 genes, tier 2 genes, tier 3 genes, everyone should have at least one, like, the NDL variant. In this, I can show you. Elizabeth sent me this file for the
Mm-hmm.
prioritization,
Yeah.
and I already prioritized for the individual files, level 1, level 2, level 3, level 4. Let me show you. In the for this one, I found it here. This is like the when I used for the OMIM table and mouse model table. This was the one I included. So if you were like any gene you were interested in this gene, so not only
Yes.
this, you can even look. I for this was the gene you were interested. So I included everything here, so that again you need not search it for elsewhere.
Mm-hmm.
So gnome frequency,
So
if
I think, Shri, that is the gene that is the most interesting so far because it's mutated in two people
yes,
or in two
Dr.
families.
Yes,
It's the same variant,
yes, Dr.
and the mouse model has an overlapping phenotype.
Yes, Dr. Nara.
So now what I want you to do is I want you to make sure that the other families don't have any type of mutation in this gene, including deletions. So can you ask Elizabeth to look with you on IGV in this gene on the other families to see if there is any deletion in there that can be found?
Yes, Dr. Nara, regarding IGV, she said she's not able to find the cram files, something like that.
All right, so what I'm going to do is I'm going to put you in contact with Gabrielle and ask Gabrielle to look with you to see if these variants have any deletion because he has the files from the long read that have CNV analysis for that, structural variant analysis for it.
Okay, Dr. Nara.
Okay?
Yes, Dr. Nara. So I think that's all, Dr. Nara. This was the one I used for prioritizing all my. Uh, why am like all my like this. I used it here in the tire level for everything I have written, 4, 3, like that, and then I didn't find anything in the tire 1, 2, 3, and only one gene with CAT score in that too in yeah, like this file, autosomal recessive file. This one with the green one, they are CAT score greater than 20. So this fits into the prioritization criteria. So I kept it on the tire. This was the tire column. Prioritization 4 for only ZNF 171 gene. Nothing else I found
Oh,
interesting, Dr. Nara, in my thing. In this merged analysis.
okay. So I have to go now to another meeting.
Yes, Dr. Nara. Yeah.
I think
get
you
it.
found something interesting that we have to follow up on. I'm going to ask Gabrielle to help you to look at the files for these other
Yes, Dr. Nara.
families and gene and variant in this gene.
Yes, Dr. Nara.
And then, when are you leaving, Shri?
On October 31st, I'm planning to go, Dr.
So
Nara.
we have 3 weeks, right?
Yes, Dr. Nara.
Okay, so let me see. Okay, we
Like
have
on
3 weeks.
November 1st, if I and Ayan go to collect chocolates on October 31st, then on November 1st I will go.
Okay, so I'm going to, we have 3 weeks. You already know how to do analysis. So I'm going to see, maybe you said you wanted to learn about the burden analysis.
Yes, Dr. Nara. Bird analysis or whole genome sequencing, whichever is fine. I want to learn.
Okay. So let me think what the next steps are, and I'll send you a message tomorrow, okay?
Okay, Dr. Nara. One
But
update,
I'm going
Dr.
to,
Nara. Regarding bird analysis, Gabriel, I talked because I need to do that for this also. So that I will do it within this week. And I have
okay.
a meeting at 1 o'clock with Gabriel. So I will ask what you
Oh,
told me
perfect.
to.
Okay. All right. Sounds
So
good
I
then.
I have to ask him, yeah, regarding the IGV for these files.
Yes.
And then the next thing, anything which you can make me learn, I will be happy to learn. So yeah.
All right.
Okay, Dr. Nara.
Sounds good.
Yes, Dr. Nara.
Good job, Shri.
Thank
Let's
you.
see what happens to that gene. It's an
Yeah.
interesting gene.
Yes, Dr. Nara.
Thank you.
Yes, Dr. Thank you, Dr.
Bye.
Bye, bye, Dr.